Hey guys, let's discuss new problem from Stack, which is implement LRU cache. So what is LRU? LRU is your, you can say it's a least recently used cache. Okay, so here what you need to do, see, we will create one linked list, okay, and we will have one hash map. We will store in hash map key and node address, okay, and whenever someone want the particular node, get one, get two, so we'll give it from linked list, sorry, from hash map, okay. And in linked list, how we will store value? We will store, if any new element come, we store after head, okay, because this one will be the recent insertion should be after head, okay. So now let's see how we will do it. So I have here one example, okay. So put 1 comma 1, put 2 comma 2. So it means that you need to put this value, okay. So let's do one thing. Initially I will have a linked list, something like this, okay. One head and one tail, okay. Or let me take space here. So one tail, okay. And what will be the structure? This one will be the doubly linked list, okay. Previous and next links will be there. So head initial value, let's say the node is storing key value pair, okay. So initial value for head is 0 comma 0, let's say. For tail also it is 0 comma 0, okay. Now so now he's saying that put 1 comma 1. So what I will do, this link is something like this initially. So head next is pointing to tail previous is pointing to head, and head previous is pointing to null, and tail next is pointing to null, okay. Now if someone asks me to put 1 comma 1, what I will do, I will put 1 just after head, okay. I'll put this 1 comma 1 after head, okay. Now next one, they're saying that put 2 comma 2. So 2 comma 2, again it should be after head, okay. So what I will do, again I will put it here, not after 1 comma 1, but after head, okay. So let's say I have inserted this 2 comma 2 in linked list, okay. So head next will point to this node, and node previous will point to head, okay. And then if this is node, so node next is pointing to head next, and head next previous is pointing to node. So we will adjust that pointers, okay. Now if someone asks me get one, so here is the thing, okay. And also we have created one hash map. Let's say this is hash map. So when someone asks me to put 1 comma 1, so I have put it that in hash map also with key 1 and then node address. So some this address, okay, memory location address. And then someone asked me to add 2 comma 2, so I have added entry here 2 and then its corresponding address, okay. Now someone is asking me get 1, so I'll check, I'll get it from hash map, okay. So I'll check if it is there in hash map. Yes, it is there, okay. So what I will do, I will get its value, I will get the key, and then we'll get that using that key, I'll get that value from linked list, okay, and then we'll return that value. But now here is the catch. You need to implement least recent used. So what do you mean by least recent cache, okay? Means which is not used from longer time. When you wanted to delete it, you will delete that first, which was not getting used, okay, from longer time. So now here if you see, okay, so if you are inserting any node in a linked list, you are inserting after head, okay. So means whatever I have after head is the recent one, right? Not the least recent, but the least recent one. So whenever you touch any node, okay, that one is getting used, okay, so recently used. So it means that you have to update that near the head, okay. So what you will do, if someone asks you to get 1, so first of all you will get its address, and from address you will get its value. Then you will remove that node from hash map, and you will remove that node from linked list also, okay. So now you don't have that node here, and you don't have that node here as well, okay. And then where you have that node, you will create that node again near this head, okay. You already have key and value, right? So you will create one node here, 1 comma 1, and then you will adjust this pointers, okay, to 10. Okay, so get 1 is also done. Now someone will ask me put 3 comma 3. So it means that again I have to put that near head only, okay. So what I will do, let me do one thing. Let me change this head here. So head will be here. Let's say this is head, okay, which is pointing 0 comma 0. This is null. And now I will create one node here, 3 comma 3, and then we'll put after head, okay. We'll adjust the pointers. Okay, now someone asked me get 2. So get 2 means and I think the size of the linked list is 2 also, right? So if it is 2, so means when you are adding 3, the size will be 3, right? Means if you don't calculate head and tail, it means that you have to remove one element, and if you need to remove that one element, which one that would be? That would be the one which is recently used, nearer to tail, okay? Because whatever is getting recently used, we are putting that near head, okay? So whatever near tail is the least recently used, okay? So you will remove, which one you will remove? You will remove this 2, okay? You will remove this 2, and then After removing this 2, you will put 3 comma 3 in a linked list, and then when next time, and then you will remove it from hash map also, right? Next time when someone come and say get 2, so that 2 is not here in hash map, right? So you will return -1. So that is the thing, that is the logic. Now let's see the code. So to see the code, you just need to understand two functions, which is insert and remove. So let me first explain the structure of linked list and hash map. So my linked list will have two integers, key and value. As I said you, okay, key and value 0, 0, initially we have initialized it, and then previous and next two pointers, okay, this previous one and next one. And then hash map will be of integer comma node, okay, and then in hash map, and then you will have few variables like capacity, head, and tell, okay, for the linked list. And all these things we have defined in LRU cache class, okay. So inside LRU cache you have created your node class, and then your hash maps and other pointers. Now the constructor of this LRU cache will take the capacity, okay, and then will create a hash map, and then will create a head and tell nodes, which is assigning 0, 0, 0, 0 initial values, and then head. So this is head, this is tell, okay. So it is saying that head next is tell, okay, and tell previous is head. So something like this, and initially so it is null, okay, everything is null. Now we will see get later. Let's jump to, so you have few functions like get, put, and then remove and insert, okay. So let's see insert. So whenever you wanted to insert some variable, okay, you will get not variable, node, okay. So you will put that node into the hash map, okay. After that, so let's say this is your head, okay, and this is your tell, and you have some nodes here, okay. So what you will do, you will insert that after head. So what it will happen, node next equal to head ka next. So let's say here head ka next is some node is here, okay, or tell is here, let's say. So this is your node, let's say, and you will insert it near head. So what you will do, head ka next is this one, okay. So this one will become node ka next. So this node ka next will become this, okay. This is node, this is next. So head ka next is this one, so it will become like that. And then node previous equal to head. So node ka previous is equal to head, okay. And then node next to previous equal to head. So node ka next or iska jo previous hai, that will become node, this one, okay. And then head ka next equal to node. So head next, this one will become node. So this is how you will insert, okay. To delete, you will delete it from first from map, and then what you will delete, you don't need to traverse it, you just delete directly whatever is just before tell, okay. So how you will get that, remove. So node previous next equal to node ka next, node next to previous equal to node ka previous, okay. So yeah, so you just concentrate on these two lines, okay. So you have given that node in a remove function, that remove this node, okay. So what you will do, let's say that node is somewhere here, okay. So what you will do, node previous next. So node ka previous, let's say here you have some other node, so it's node previous next. So node ka previous is this one, and it's next, what it will become, head ka next, node ka next. So node means this one will become like this link will break, okay. And then after that, node next previous. So this is node, its next is this one, and its previous tell, okay. And tell's previous will be node ka previous, node previous is this one, so this one will become like this, and this one will, you will remove it, okay. So this is insert and remove. And then get and put is simple, okay. So get, whenever someone will tell you that get that key, so first you will check that in a map, okay. If it is not in the map, just directly return -1, we don't have that key. Otherwise if you have that key in a map, you just get its key, store in a node, okay, and then remove that node first from linked list, and then insert that node, and then insert that node in a, again after head, okay. Similarly for put, okay, you need to put some value in a linked list. So first you will check if it is in map. If it is there in map, then remove that from map, okay. And then if map size is equal to capacity, so here we will delete our function, right. So if node map dot size is equal to capacity, that time you just remove whatever I have in tell ka previous last second node, okay. You will take that in LRU and then remove that LRU. One more thing, so when you are removing it, you're inserting that node first, okay. If you are removing that node, so first you will remove it from map, and then you will insert that in a linked list, and then you will adjust the pointers. So that's it. Thank you.